Alright, this problem is number 13 on the 2019 AIME 2. A regular octagon is inscribed in a circle of area 1. A point P lies inside the circle so that the region bounded by PA1, PA2, and minor arc A1, A2 of the circle has area 1/7, while the region bounded by PA3, PA4, and minor arc A3, A4 has area 1/9. So there's a positive integer n such that the area of the region bounded by PA6, PA7, and arc A6, A7 is 1/8 minus rad 2 over n, and we want to find n. So first we draw our diagram. So here we have an octagon with its circumcircle and the point P connected to all the vertices that we need. So first, we notice that this is a regular octagon, so that means that all of its sides are equal. So we can call the side length S. And notice that since each of the side lengths are equal, then the area of the region bound between the chord and the arc are also equal. So we have first that this area is 1/7. Now, notice that if we draw in the origin, or the center of the circle, then and we call that point O, then the area of OA1, A2 is 1/8 because it divides the circle into 8 equal parts. So notice that since they both share the same area between the chord and the arc, which means that the difference in the areas between these two regions is the same as the difference in area between the two triangles PA1, A2 and OA1, A2. So this means that we have the area difference is 1/56. Now, notice that they share the same base, A1, A2, which means that the difference in the heights of the two triangles is the area multiplied by 2 and divided by the base, because area is base times height over 2. So this means that the distance, the difference between the heights is negative is 1/28s. And we notice that if we consider this as a coordinate system, then this means that the y-coordinate of P is negative 1/28s. Now, similarly, if we consider the other PA3, A4, so that would be this, and then we compare it to the region OA3, A4, then by the same process, we have that the area difference between the two triangles is 1/72, which implies that the x-coordinate is 1/72 times 2/s, which is 1/36s. So now we have the coordinates of the point P. So how can we find the area of PA6, A7 compared to the area of OA6, A7? So notice that A6, A7 is parallel to the line y equals negative x. So that would be this diagonal line that we have here. So now what we want to do is find the distance from P to this line y equals negative x, since that would tell us the area difference between PA6, A7 and OA6, A7. So since we have the coordinates of the point P here, then we want to find the distance PQ, where Q is the midpoint of the point P reflected over the line y equals negative x. So if we look closer at this diagram here, we have that R is P reflected across y equals negative x, and Q is the midpoint. So as we can see, the coordinates of the point R is just 1/28s, comma negative 1/36s, and Q is the midpoint of PR. So that means that the length of PQ is just the length of PR over 2, and the length of PR is 1/36s minus, or 1/28s minus 1/36s times square root of 2. and this is 1/2 times rad 2 over 126s, which is rad 2 over 252s. So now that we have the length PQ, we can find the area difference between PA6A7 and OA6A7. So the difference between the two areas is PQ times S divided by 2, and this would give us rad 2 over 504. And notice that since the area of PA6A7 is less than OA6A7, this means that the area of the region bounded by PA6A7 and the arc A6A7 is just the 1/8 minus the area difference between those two triangles, which is rad 2 over 504. So therefore we have that n is equal to 504.